Morning. I'm going to start shortly. I'm busy recording. I have received messages of people struggling could- to connect because of load shedding and those kind of things. So I thought let us start. I will also make the recording available afterwards. So the guys that unfortunately can't connect this morning, I will share the recording afterwards, also the presentation. So again, to the guys that is not on our WhatsApp group, let me just put in the link again so that you can via the link connect to the WhatsApp group. Else you can um, send me a message on 083 790 8387, and I will add you to the WhatsApp group. So just if you're not on the WhatsApp group and wants to be on it, there's a link in the chat, or you can send me a WhatsApp and I will add you to that group. Okay, so I know more people will be joining. So as we go along, um, the focus for today is we're going to start with chapter 6 and just see how far we can get. So hopefully we can finish some work today. So chapter 6 was nearly a follow-up on chapter 4, chapter 5, that looked at differentiation. If you can remember, we looked last time, and that was about two weeks ago, at the different differentiation rules, and how to use those rules when you need to solve questions. So basically, what application of differentiation is that we introducing some of the economic work that you're also doing into this, and in the end you will still differentiate equations, um, but it will be around some other concepts like average and marginal cost. So we will definitely look at average cost and marginal cost. It nearly comes from chapter 2 and 3, where we looked at total cost and those kind of things. Then from this marginal cost and average cost, we will work out marginal revenue, and link to that some more cost functions. Then we will also go into using this average revenue and cost functions, um, from working from total revenue and total cost. So there will be a big link between this and the previous chapters. Then we will also do some just look at some economic functions around that, and then we will look at elasticity, like in your chapters 3 and 4. We will now just look at the elasticity for a nonlinear demand function. Okay, so what I'm also going to do, we're going to work through a lot of this, but the next session I will bring in a lot more examples, so that we can also focus on the examples. Probably the next session we will just round off all the stuff that we haven't done yet, so that we just need to decide when that is, because next weekend is a long weekend. So but we will probably make it sometime in the week, and then after that, we will start preparing you guys for the exams. Um, as far as I know, you're still writing on the 28th of October, but when that changes, you can also just let me know. Okay, so I'm also just adding into the chat the WhatsApp group number so that anybody that can still see it can join. Okay, so remember, and now we go back again to chapter 3, where we looked at total revenue, total cost, fixed cost, and variable cost. So what is very important about this chapter is we're going back into all the previous work that we did. So a big link again between what we did in chapter 3 and 4 with chapter 5 and 6. And then when we go into integration, which is the next chapter, a big link then again back to differentiation. So when we get to chapter 7 and 8, basically integration is just doing the opposite than differentiation. So, but again, you guys don't need to, this is in your study guide, but I also thought the most important one nearly is to look at this table so that you can see the links that we're going to work with. So going from total revenue to marginal revenue to average revenue. So when they say anything about those functions that we need to work out, you can basically know that you can look at so if I ask us to work out something around average revenue, we can then look at the total revenue curve. So again, what is important from this table nearly is that you just know the links, because it's not always that clear when we talk about average cost that we need to calculate how we get to it. So I just thought that's why I wanted to show you this. So when we look at, we will normally get the total revenue function or total cost, fixed cost, variable cost. So if we differentiate that function, the next function that we will get is your marginal functions. Okay, so and basically it's what they are telling us here. So if we differentiate the function, you will get your marginal. And then to get to the average, you basically divide by the quantity. So that is then how we will get to that. Okay, so let's go into one of the first ones. When I talk about marginal revenue, so what they will, when we looked at marginal revenue, and again, look, marginal revenue is linked to total revenue. So now we need to nearly remember back, your total revenue was equal to, what was it, P times Q. And then normally we will substitute one of those. So they can give you a demand function, or they can give you a supply function, and we will normally substitute one of those with that function so that we can get your total revenue. So normally what will happen is that your total revenue function will have a q to the power of 2 in it. Okay, so with that, then it's easy to say, well, if we differentiate something that's q to the power of 2, remember from the previous chapters, it will become 2q, and obviously there will be something linked to that, so that we can nearly say, if there was more info, that we can nearly put it into a formula to solve q. And then we have q, so we can then put q back into one of the originals to then solve p. Okay, so that is nearly the process, how it's going to be for all of these functions. So from your total revenue, total cost, and variable cost, that is nearly the process that is going to be every time. So I think that is why I thought it's important that we just again look at this and what will happen in this process. So what I've done, and this is also, I think, in your study guide, but let's just make it a bit bigger so that we can actually work through one and just again look at what we need to solve. Okay, so they tell us in this example that we sit with a demand function. They tell us the demand function is P is equal to 6 minus 0.5Q. So we need to go again and work out marginal revenue. Okay, then we need to remember, okay, to get a marginal revenue, I need to differentiate total revenue. Okay, total revenue, we need to remember is P times Q. Okay, we have P, so we can basically substitute P in this formula. So we can then work out what our total revenue curve is going to look like. So it is going to be 6Q minus 0.5Q to the power of 2. Okay, so that is our total revenue curve. By just giving us one piece of information, we could have calculated that. Okay, so now the next step is that we need to remember from, again, to get to a marginal revenue, we need to take the total revenue and differentiate. So when we do the differentiation rules, this one is the simple one. So whatever is at the top of the exponent, take forward, multiply. So it becomes 6Q1 minus 1. So in a sense, that will then disappear just to be 6. 2 goes in front. 2 times 0.5 is 1. Then it is Q2 minus 1. So that next step basically makes it that our total revenue, or our marginal revenue, sorry, is equal to 6 minus Q. Okay, so then they could have asked us, but, and here now they told us, well, from the marginal revenue, we find that when 5 units have been sold, the revenue from the next unit sold will be. So it's basically, we then substitute into that formula. But what they could have also asked us is just solve Q for the marginal revenue. So we could have done it just this way as well, that your Q will be equal to 6. Okay, so depending on what your next set of information is, you can do a few different things. Normally, we will actually follow this route, so that we need to calculate Q. When you then calculate Q, you can go back, so substitute the Q into your original formula, that you also get a pricing linked to that. So that is how it normally happens, but also they can ask a few different things around this point depending on what they want to do. Okay, but if we needed to work out the P, we could have just substituted into Q. Okay, so that is nearly the process that is going to happen every time that we need to work out a marginal revenue curve or function. And the important thing is always to remember marginal revenue goes with total revenue. So what I would do if I were you is, and let's just clean this up a bit, is that I would take this piece and nearly make a printout of it, or have it just somewhere close to me, so that I nearly know every time that we talk about something what I need to look at. Okay, so the same will follow with when we look at marginal cost. We will again, and you can see I don't remember all these things because there's just so many things to remember. So when we need to do marginal cost, we look at total cost. Okay, so then we need to remember, okay, if we look at, so we need to look at total cost to get to marginal cost, but total cost again is a function of your fixed cost plus your variable cost. Okay, so again, just remember total cost is always a function of a fixed cost plus the variable cost. So you will actually work out that function, differentiate that function to get to your marginal cost. So same principle will apply. So let's look, there's supposed to be example now. So let's just make this bigger as well for you. Okay, so now again, depending on what they give us. So they could give us in a formula or in a question, they could give us your fixed cost. They can talk about your variable cost, so that you need to put it into a total cost function, or they can give you a total cost as we have here. Okay, so sorry, that's just taking a sip of water. So your total cost, again, we will need to differentiate to get to your marginal cost function. So if I give this to you, you can just differentiate that. So if you differentiate that, the simple way again is to say, well, there's nothing linked to a constant, so that will disappear. Q1 minus 1, so we're actually sitting with a marginal cost of 40. Okay, so that very interesting. This is one of those that's a very simple function. It's more, if I look at that, your traditional function that you will have in study unit 2 and 3. But what might happen is more the one that is in question 2. So here you can see much more of information. So this is not just a simple cost line, it's actually a cube cost. So a lot of other things in here. But again, you don't need to know how a total cost was structured. You just work with that function. So if we need to work out marginal cost, we remember, okay, marginal cost again, we need to differentiate the total cost. And then if we differentiate, again, we use the first, I think it was the power rule that we nearly looked at. So 3 goes to the front, 3 times a third is 1. Q3 minus 1 gives us q to the power of 2. 2 goes to the front, so 8 times 2 is 16. Then q2 minus 1 gives you q to the power of 1. And then q1 minus 1, so we just take the constant or the part that's in front of the variable, and that is your marginal cost function. So let's just rewrite it a bit better. So then they can give you like in the previous question with total, with a total revenue or the marginal revenue, they can then tell you, okay, but when Q is something, work out that marginal cost. So they can give you then a value for Q and substitute it. Otherwise, we can also work it out by saying, okay, what will your marginal cost function look? Okay, so we might, so if they don't tell us substitute Q with 15, we might just want to solve what Q will be. So then we need to, and you might have done this before in one of our other subjects, so we will need to solve Q by basically finding the factors. Hopefully there's an easy one here. I look at 120 to get to that and get to 16, probably not the easy one. 120 times, so what will give us 120? 6 times 20, then I'm not going to get that. 12 times 10, also not that. Okay, so I will look for you what that answer is and share it later on. It's 4 and 20 gives us 80, so that's not going to work. Okay, so I'll see it's not as easy as I thought it would be. So I will get us an answer to this, but basically what will then happen is that you sit with 2 values for Q that you can work with, but else they can just ask you to substitute Q. And this will bother me now, but I will get to just make a note for myself and I will share that afterwards. Okay, so what we've now done is we looked at the total revenue, we looked at the marginal revenue, we looked at total cost, which is a function of fixed cost and variable cost, and we looked at your marginal cost. So the next step then is to look at the averages. Okay, so we've looked at the marginal revenue, marginal cost. So next step is to look at the averages. And so if we look at the averages, the only thing that will be added to this is that your average revenue, you would just take your total revenue and divide it by Q. Okay, so that is what will happen with your average. The same if it is the next slide, unless we have an example. Okay, so we've got a few examples. So let's just, the same will happen with your average revenue and average cost. So sorry, here's your average cost. Again, very similar. If you look at your average cost, it will be your total cost divided by Q. Okay, so basically with the average revenue, average cost, this, what will happen in this instance again is they can, and let's go back to that original table, they can give you total revenue with a bit of more information. The first question can be work out the marginal revenue, and then the second question can be around average revenue, or they can go straight from total revenue and ask you by giving you enough information to work out the average revenue. So again, that's why I nearly like this table, just to make sure that we've covered everything from the one to the other one. Because also when we get to integration, what will happen is we will move backwards again. So integration, I also have this table, but then what will happen with integration is we will move from marginal revenue back to total revenue. So just nearly where the links are in this chapter then to the next chapters that we will do as well. So here we differentiate. When we get back to that we need to move from marginal to total, we will integrate again. So, but that is for later. Okay, so we've looked at average revenue and cost functions. Now let's look at examples of that. So what they tell us here, and let's skip that one. Again, I'll share it with you. Let's get into one that there's really a lot of information. So they tell us, yeah, they give you the average cost. So they tell you this is the average cost function. So if we need to then find out what is the total cost, remember the average cost was total cost divided by Q. So if we need to move from average cost to total cost, we need to say, well, average cost times Q will give me the total cost. So then if they give me that total cost function, I just substitute it into there and I work out what my total cost is. Okay, so then does make it a bit simpler if we know that. So if we then multiply that by Q, we will get our total cost. The total cost will be, then multiply that in that, and that. So we will sit with 2Q to plus 5Q. And then that one will be plus 50. Okay, so what we've done here now is we've worked out our total cost. But they could have asked you to work out what is your marginal cost. So by just giving you the average cost, they could have, here we've now worked out the total cost, and then from there worked out marginal, or we're going to do that, but they can ask you directly, here's an average cost function, what is my marginal cost? So they don't need to guide you step by step how to get to it. You basically need to know that if I get my average cost, I can work out what the total cost is by multiplying by Q, and then I need to remember, okay, but if I take my total cost, I differentiate it, I get my marginal cost. Okay, so they can ask you this without nearly guiding you first to work out what the total cost is. So that's why it's important that you guys need to remember nearly that table. So if I give you average cost, you multiply that by Q to get to your total cost. Then we remember from that second or third slide that total cost, if we differentiate that, we will get our marginal cost. And then around the marginal cost part here, just like in the previous examples that we worked out, they can now say, okay, but if my production is so many units, what will the marginal cost be? So if I tell you, well, it is where Q is equal to 50, you can substitute it into Q, and then you get something like 120 plus 5 is 125. So that could then be your marginal cost. In this example, they said at 50 units, but again, it can be any number that we want to give you. Okay, so that is nearly, once again, how we work with, if I give you total cost, total revenue, if I give you average cost, the same year would have, if it was average revenue, so if it was average revenue, would have been exactly the same. It would have been total revenue. And let's just see where that was, total revenue divided by Q as well. So if we needed to work out your marginal revenue, would have been exactly the same. Average revenue would have been your total revenue divided by Q. So then we will get a total revenue that is average revenue times Q. And then if we need to get to your marginal revenue, it would be that function that we will need to differentiate. Okay, so that is nearly the important links that I wanted to show you guys this morning, around the nearly how to get from total revenue and total cost to your marginal revenue and marginal cost. But also if you get average cost and average revenue on, you nearly need to work that back into first your total revenue, total cost, and then work out your marginal revenue and marginal cost. Hey, any questions thus far? And I don't know if all of you received the message. So we have started a bit earlier because unfortunately I need to leave at 10. So the session will be until 10. Next week, it's a long weekend. So UNISA is not allowing classes next week or next weekend. So we will somewhere, there will be just a update for us to have a session in the week, but I will also communicate that with you guys on WhatsApp so that we can just get a suitable time for that. And then also, if you're still not on the WhatsApp group, there is a link in the chat, but also my number is 0837908387 if you want to join our WhatsApp group. Okay, so let's go to the next section of this. So we go into the production functions. I was just thinking there's always one of these questions nearly in your exams, but it is normally linked to another function that you would have done. So when you look at the production functions, and I will get you some examples of that as well, because what I've seen in the last few years, what they do is they link it maybe to exponential or a log function, and then you need to calculate that. So let me just, this is very small. Let's quickly, sorry about this. Let's duplicate this. And we can just make it much bigger on both sides. Okay, so this was again one that was in the book. I will get you a nice one that is different from one of the previous exam papers. So in this example, they just tell us, okay, suppose the daily production function is this. We need to work out what is your marginal product of labor. Okay, so in this instance, when you look at that, very similar to the previous work that we looked at, total revenue or anything like that, and we need to take it a step further. So they give us the production function, and the only thing we will then need to do is actually to move it one step further. So if that was the production function, we need to differentiate that to get to your marginal product of labor. So, and that is why I say sometimes they make this function a different function, because remember in study unit 5, when we looked at all the product rule or all the rules with differentiation, remember we also looked at exponential and log. So sometimes what they will do here is give you an exponential function, and it nearly throws one off because it's like, but I haven't seen something like this before. But you have. So if they would have asked you to differentiate a log function, you would have been able to do it. So all that they're doing then is changing the wording, but you actually know how to do it. And that is why I will get you an example or two of that. I know exactly, I can picture the two questions that I want to share with you, so I will get that for you, because again, sometimes in the exam situation, you see something strange like that, and then it just hits a blank. But actually, if we just calm down and just remember the things that we've done, it's like, ah, but I remember that. So I will share. So if we look just at this one quickly, we needed to work out the marginal product of labor. So again, differentiate. So the 2 goes to the front. 2 times 15 is 30. 30L. It would be 2 minus 1, which is actually just 1. Then minus 3 to the front. 0.5 times 3 gives you 1.5. And then it is L, and 3 minus 1 gives you 2. And you will see that is exactly the same. And then again, I can tell you if L is this, work out your marginal product of labor. So then you just substitute whatever they tell you into L, so that you can work out what those production rates are. Okay, so this is nearly just an example of working with your revenue, total revenue to marginal revenue. So this is just a different example of actually using that information. Okay, so let me just quickly go. So let's continue. So the second part of this chapter looks at optimization of economic functions. So again, we have actually done it. Now we just call it again something different. And I think that is sometimes where in DSC 1520, what happens is a lot of the things that we do is repetitive, but we call it different names. And that becomes very confusing again when you sit in the exam situation and you actually know what to do, but now suddenly we call it something different. Because if we look at optimization of economic functions, it's exactly the same that we just did. So if we talk about the demand functions, they will give us a demand function. But remember, so if we have P, to work out your total revenue is P times Q. So what will happen just is that we will substitute that into P. So then our function will look like something like this. And then you can go on and work out the rest. So the important thing nearly again with these last few examples, and yeah, we're not going to go through all of them, but it's nearly just to get the links every time. So in this one, let me just get my draw back. So in this one, what they've given us is just the demand function. We need to remember, okay, if I need to work out marginal revenue, okay, they don't give me enough, or they don't talk anything about marginal revenue. But wait, to get to marginal revenue, I need to get total revenue. Okay, and then it needs to click, okay, when I have total revenue, well, to calculate total revenue, I need to say P times Q. And then it's like, oh, but I have P, I've got Q, I can get to total revenue. So that is how it's going to be with all these functions, is they, every time they give you a bit of information, and you need to work out the rest. So in this instance, like I said, now they give you suddenly a linear function, which again, now if you look at that, it's like, oh, shucks, what must I now do? Because linear functions, we haven't worked about any linear functions, but the same principle applies. So we've got a demand. So from demand, we need to get to total revenue. So total revenue is P times Q. So just follow the process. And we've got P, we substitute that in. And that is why it's nearly, okay, so just follow the process. So that becomes 24Q, Q times that, so 6Q ln Q. Okay, so that is your total revenue. And then from where we need to get to marginal revenue. Okay, so now, and that is what sometimes makes this difficult. Now it's like, oof, marginal revenue. Okay, I need to differentiate that one. Okay, now you need to nearly go through study unit 5 and look at all the differentiation rules. So is it product rule? Is it quotient rule? Is it so nearly go through those rules to see how will I differentiate this? And then it's like, okay, I remember it's a product rule. So when we have a product rule, let's look at, this one is easy when we differentiate the first one. That's 24. When we differentiate the second one, that's a bit different. So we can take 6 out of there. So now you need to remember, oh, okay, differentiate the first one times then the second one. So if we differentiate Q, okay, it's 1. Keep the second one, ln Q, then it is plus, okay, differentiate that first, take that first part, it's Q, differentiate ln Q. So remember, ln Q is 1 over Q. So that is where study unit 5 now suddenly becomes very important in this instance, because you now needed to remember what the product rule is and how you will calculate that. So then ln Q stays ln Q. We can't do anything about that. Q times 1 over Q becomes actually then plus 1. So Q will go to the top. Q divided by Q is 1. So then if we calculate this out, minus 6, which will then give us 18 minus 6 ln Q. Okay, so this is nearly what I had in mind when I were talking about the previous ones. It is when you look at this from the start, it is like, sure, where do I actually start with this? But it is nearly following the steps. So first thing to remember is they give you the demand function. Then it needs to click, okay, from a demand function, I need to get to the total revenue function. From a total revenue, if I differentiate that, I move to your marginal revenue. So that is all fine, but now the extra difficulty that comes into this equation, or this one specifically, is that you're now sitting with a ln function, and it's not just a simple ln function. You need to see these two terms, so I need to use one of or the product rule, or the chain rule, or the quotient rule, and with that, you will get to your final answer. Okay, so this is nearly the worst case type of question, because the other one that I also like to ask, and I don't know if I have an example of that. No, so the other one is normally where they give you a E question. So we don't have something like that. But I will again just look. Sorry, I see my mic went off there. So what I said was, the other one with ln is normally the exponential one. So I will get you an example of that as well. Okay, so I'm gonna share this back with you after the session as well, or later today. So I'm not going to go through everything. I just want to check if there was not something else in here that we could have. So the next one in part of this study unit is when we look at elasticity. And again, we've done elasticities with linear functions. Now we need to work out elasticities with nonlinear function. And again, there is a few definitions or formulas that you can use. And again, please don't go and remember them. I will share with you a formula page that I have put together, that nearly over a few pages covers everything that you guys need to know and how it's linked to everything. So I will share that. But basically, very similar to what we've done in, I think, chapter 3 or 4, when we looked at elasticity of demand for linear function. We will get information. You need to then use that information by looking at one of the two equations. Use that information. So if you then need to find out what the difference is in Q divided by the difference in P, or if you need to work out what the derivatives is, you will get enough information to do that. Okay, so let's look at, and here I brought in the exponential one. So if we needed to find out what for this exponential function, what is there's elasticity of demand that's linked to this. So here we sit with a function. Let me just get my draw back. So here's the function that we're looking at. So if you look at that, we need to differentiate that. So again, if we go back to slide 23, that is what we need to do to get your elasticity. So we need to differentiate that. Look, now we need to remember differentiation with logs. You basically keep the front, then you bring that forward, and when you bring that forward, the second part stays the same. Okay, so that is when you differentiate that formula. So look at, it's the first part, you bring that component in, and then the second part stays the same. So yes, now you can make it a bit simpler. But because you're gonna, in any case, use a calculator, you can decide if you, at this stage, want to make it simpler or if you work with it as is. And that is all up to you. So, but then the next step is, so we've done the differentiation part. So let's make it a bit simpler. Now we need to say, okay, I need to multiply it by P divided by Q. So we could have now said Q, but remember there is Q as well. So it looks like a very complex question or answer set, but let's just simplify it a bit. So this is all nearly at the top. So we can say P, that will be multiplied by P divided by, what is it, 45. 'Kay, so that and that cancels out. So minus 1.8 divided by 45. 1.8 divided by 45. So that is 0.04. And then we just left with that P. Okay, so originally it looked like a crazy kind of situation. But again, by differentiating that, we got to that stage. We needed to put it back into the formula that we will use to get the elasticities. So that again is really an important formula for you to use. Again, you don't need to know how you got it. You don't need to worry about that. And then if we substitute, normally what will happen in if you need to work out elasticities with or exponential or with a Lin function, it will normally, there will be things that will cancel out so that you sit with something simpler that you can work with. Okay, so that's normally how it will be. So you will not sit in a function like this with something weird that you will end up with that's still, there's still a e to the power of what in it and things like that. So when you work out the elasticities, what will normally happen because of this function q that's sitting here, and you differentiate it, there will normally be something in common that you will cancel out in the process. Okay, so when you get to exponential and ln functions with elasticities, there will always be something in there that will normally cancel it out to make it a bit simpler. Okay, so the next one, again, gonna share it. It's just looking at, there's some more examples. So now we go into integration. So just quickly want to take a breather. Okay, so integration. So within integration, there's going to be a few things that we need to look at. In the chapter of integration, basically, going to look at what is the simple concepts about integration. Basically, integration is the reverse of differentiation. So what if I had something simple like this? We will need to basically go to integrate that is the reverse of what we did with differentiation. So we'll work out functions like this to show you how to do it. So basically, the integration is just the reverse of differentiation. Obviously, because there was certain rules in differentiation, we will also work with some rules in integration. So there will be power rules, there are other things that we need to substitute, integrate things. Then we will also look at differences between, if you look at the curves, so depending on the type of curve, where it cuts the x-axis, if there's turning points, if there's maximum and minimums, we'll look at that in this chapter as well. Okay, so nearly the first part is what we look at is to say, well, we need to do the reverse of differentiation. So if this was my formula, and I need to integrate that, what I will do is say, well, there was my one. With differentiation, we would have added the minus one. So with integration, we add one back again. Okay, but then what we need to do is whatever is on top there, we will need to divide by. Okay, so we've got 2x to the power of 2, but we will need to divide by what's 1 plus 1 is 2. So if we needed to integrate that, it would have given us x to the power of 2. So again, a few simple steps that we will need to go through. Okay, so that is a very quick show of how we will move from a number that was differentiated back into the integration. So obviously this will become a bit more difficult. So we will look at more complex formulas. So where it might be one or two functions, we might look at complex functions of, again, exponential. We might look at complex functions of ln or log functions as well. So we will get to that, probably not today, but we will go through some of those. What I also, so you would again see there's a lot of information in these slides, but the first rule again is the power rule. So like in your differentiation, I think there was a power rule. So the same happens with your integration. The first one is a power rule. So we've nearly looked at something like that. Let's look at if I need to integrate this one. So x to the power of 5. So if we needed to integrate that, what we will do, we will add 1 to the top, and then we will divide by what that was. So we will divide by that whole thing. So if we needed to integrate the x to the power of 5, it will become x to the power of 6 divided by 6. A test for you can again be, but again, you don't always have time in the exam, but while you're practicing, is to say, okay, but now that is my integration. Let's quickly differentiate that. So if we differentiate that, 6 go to the front. Remember differentiation, it would have been 6 minus 1, and we have it divided by 6. So that will disappear because 6 divided by 6 is 1. So we could have tested it and see, okay, cool. I actually get x to the power of 5. Okay, so that is a way of testing it. You won't, and let's be honest, in the exam, you probably won't have lots of time to do something like that. But while you're now practicing and doing assignments, but that is also probably done nearly, you can nearly look at it from that way and see, okay, let's quickly test if we can get then the opposite again. Okay, so that first one is the power rule, and this basically is, if you want to jot it down, if you want to look at it, let's basically look at what the definition is for the power rule in general. So if you needed to use integration, so whatever your function is, this is how you would normally go about. But remember, it's only there for that one function. So if you have multiples, you will just repeat that process for multiples. So if I had, let's say, x to the power of 2 plus x to the power of 3, you will just do it for that one and for that one. Okay, so for this one, we would have said 2 plus 1, so it would have been 3, and then we say divided by 3. This one we would have said, okay, 3 plus 1 is 4, but then divided by 4. So if you have a formula that is then just two terms that is divided by a plus or minus, then you can just use this on both of them. and work it out like that. Okay, so that is when we need to integrate two terms that is just divided by a plus or a minus. Okay, then you can also look at the one. Let me just quickly check where that is. Okay, so this is an example of what I've just shown. I want to get to one of the weird ones. Okay, so there wasn't, I thought I had a lin. Okay, yeah. So, and this is more again to remember from your study unit 5 when we looked at differentiation. When we differentiated ln x, we said it's 1 over x. So now when we actually have 1 over x and we want to integrate it, we will then move back to ln of x. The one thing that you will see that we add is in a lot of the functions we will add plus c. And the simple reason for that is we don't know if my original was ln x plus 5. Because when we integrate, when we differentiate a constant, it disappears. So what you will see is with a lot of these functions is that we suddenly put back a c into the formula just because we don't know if your original there was a constant. So again, if we had a constant which we differentiated, it would have fallen away. So the technical way is to say, well, let's then just add a c back if we integrate. If there wasn't one, the c would be 0. Okay, so that is nearly a placeholder for if there was a constant. And you will see a lot in your assignment and in your exam. What they will do is normally add the c. So if you needed now to integrate that, they will normally have that as an option, but they will normally across the board add a c to all the options. So they will not be a option in your exam, but that is one option and this is another option. They will not do that. So there will rather be a few different things that the ln x could be, but all will have an added c to it. So very seldom that they just show you the ln x and another option is ln x plus c. So they will not do that, but normally what will be in the option sets, they will add the c. So don't think that everything is wrong now in that options. It's just the constant that we bring back into the system. Okay, so we've got another few minutes. So let's just do one more. And this is where we look at, and again, if you look back to what we did at differentiation, where we needed to substitute one of because we were working with two formulas. Now we're going to do the same. So now we're going to do integration with a substitution. So very similar process that we're going to follow. So we're going to say, well, that term there, we're going to replace by u. Okay, so then we actually have u to the power of 3. So now we need to integrate that. So u to the power of 3, if we integrate, we follow exactly the same process. It's u 3 plus 1. We divide it by the 3 plus 1, which is 4. So we have u 4 divided, u to the power of 4 divided by 4. Okay, so that is what we have, and then it is just like we did with differentiation. But now we need to substitute back again. So 4x plus 3 to the power of 4 divided by 4. And then, as you will see, okay, what happened here? Okay, so they just moved that to the front. And let me just quickly see what else did we. Okay, we also needed to differentiate the thing in the middle. So that would have been 4 that we need to integrate. So I forgot about the one in the middle. Okay, so that is the part that we needed to add to it. Okay, but then also important again, the C, because there could have been, in the original, it could have been just a constant. Okay, so there's definitely, you will get something like this in the exam, where you will get, with the substitution for differentiation, you will get a question. You will also get a substitution with integration that you need to be able to do. Okay, so that is it for today. Sorry that we're having a shorter session today, but unfortunately, some personal matters that has happened in a week. So, but I will share sometimes with you that we're gonna have the next session because of a long weekend of next week. Eunice, I don't have any weekend sessions next weekend, but we will manage it so that we can still get in a session all this week in the week, or then we'll just move it to next week sometime in the week. Okay, thanks everyone. Have a good weekend. I will share the recording